Good afternoon. We are going to do notes from 3.1b, how to write a line of reflection given a drawing or the points of a pre-image and an image. So what we're trying to write is the line of reflection, which is a line equation that goes right there in the reflection statement. This is the figure we're going to use. The ABCD is the original or pre-image. A prime, B prime, C prime, D prime is the new image. So the main idea that you need to keep in mind when looking for a line of reflection is that the line of reflection is the perpendicular bisector of the segments joining matching letters. So let's write that down. Line of reflection is the perpendicular bisector of the segments joining the vertices. So for example, A to A prime, B to B prime. In all cases, it's the perpendicular bisector. So first thing you want to do is, if you have a visual, draw a line. If you don't, you can just use the formula. But we're going to draw a line from from A to A prime. And we're going to draw a line from B to B prime. Now our line of reflection is going to be the perpendicular bisector of those two segments. So to figure out where the center of the segment is, you need the midpoint. So our midpoint formula, which we've learned in previous units, is the average of the x's, so x1 plus x sub 2 divided by 2. The average of the y's, y sub 1 plus y sub 2 divided by 2. So starting with A and A prime, it's the average of the x's, so negative 2 plus 2 divided by 2. The average of the y's, 0 plus a negative 2 divided by 2. Negative 2 plus 2 is 0. 0 minus 2 is negative 2. And the resulting point is 0, negative 1. Let's put that on our drawing. 0, negative 1 is right there. Well, now we need another point, so we're going to perform the same operation, except we're going to do it with the B values. So we're going to find the midpoint. Oh, this says D. We're going to do it with the B values. So let's just replace that. B prime. So average of the x's, negative 3 plus 5 divided by 2. Average of the y's, 3 plus a negative 1 divided by 2. Negative 3 plus 5 is 2. 3 minus 1 is 2. And we get the point 1, 1. Let's put that on our drawing. 1, 1 is here. So our line of reflection is the line that passes through those 2 points. That is our line of reflection. So what we need to do is find the equation of that line now that we know 2 points that it passes through. Okay, so for starters, we need to do the slope of the line. So remember your slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'm going to designate these points x1, y1, x2, y2. Put them in the slope formula. So 1 minus a negative 1 over 1 minus 0. A negative times a negative is a positive, so 1 plus 1. 1 minus 0 is 1. We get 2 over 1, which is a 2. That is the slope of our line. Now, the format of a line of reflection is slope-intercept form. Y equals mx plus b. And in this form, you need the slope, which we have. You also need the y-intercept. Now, in this particular case, we lucked out, and we actually got the y-intercept here. The b is going to be a negative 1. But let's say that you didn't have that, and you're trying to calculate it. What you would use is a temporary point, xy. So I would probably pick this one as my temporary point, and the slope, and then you would solve for b. So temporary y is 1 equals slope of 2 times your temporary x, which is 1. And I'm using this point for temporary purposes, plus b. And that's 1 equals 2 plus b. We subtract 2. We get negative 1 equals b for our y-intercept. So our equation of the line of reflection is y equals slope of 2x minus 1 for the b. Now that we have the line of reflection, we're going to write what we call the rule. So when they ask you for the rule, this is what they're looking for. It's the notation. So we have a reflection, capital R, and then we put our line of reflection in the subscript, y equals 2x minus 1. And we reflected a parallelogram, A, B, C, D, and the new parallelogram is labeled A prime, B prime, C prime, D prime. This is the rule. Now, don't confuse this rule with a point-to-point rule. This is a shape-to-shape rule, where you're actually using the vertices of the shape to write the rule instead of x and y as generic points. So this is the shape-to-shape rule. That's what we've just done. Okay, flip the page. Now we're going to write a point-to-point rule for the shape that's given. So make sure you put that up in the title. I find people get this confused. So we're going to write the point-to-point rule. And if this graph paper doesn't show up on your printer or on your copies, feel free to grab a piece of regular graph paper and do these notes on regular graph paper because you really do need the squares. All right, so first thing we're going to do is we're going to do this using visual, the graph, and then we're going to do it using the points only. So I can show you two different ways to attack this. So let's first plot the figure. J is 1, 0. K is negative 5, 2. 1, 2, 3, 4, 5. Up 1, 2. L is 4, negative 4. 1, 2, 3, 4. 1, 2, 3, 4. And we connect the vertices. This is actually a triangle. All right, there is our pre-image. Now we're going to plot the image, the result. J prime is negative 9, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That is our J prime. K prime negative 3, 2. 1, 2, 3, 1, 2. That's our K prime. And then L prime is negative 12, negative 4. So 9. I put a negative on there. 9, 10, 11, 12. And down 1, 2, 3, 4. So L prime is negative 12, negative 4. And we're going to join these points so we can see the shapes. And that is our new figure. Okay. So sometimes the line of reflection is slanted, like on the first page of the notes. Other times it is not. You can use midpoint formula, but if it's already drawn out, or you can easily plot it, many times you can find the midpoint by counting spaces. Negative 9 plus 1 is 10, so if I count 1, 2, 3, 4, 5, 5 is the midpoint. Obviously this midpoint is here. And again, we're looking for the midpoint of the segment that joins the original vertex to the new one. Draw a line through this. And that is a vertical line. So remember that the equation of a vertical line is always x equals the number where it crosses the x-axis. a horizontal line, the equation is y equals the number where it crosses. This crosses the x-axis at -4. So my equation is x equals -4. All right. So if we had to write the shape-to-shape rule, this would be capital R for reflection across the line x equals -4. That goes in the subscript of triangle JKL is equal to triangle J prime, K prime, L prime. Okay, so that's the shape-to-shape rule, but we're also going to learn the point-to-point rule. So what you want to do first is list the coordinates old to new. So if I take the x coordinates from the original points, my -5 became a -3. My 1 became a -9, and my 4 became a -12. So the y coordinates in this particular case, let's do the same thing. You're going to notice something in a pattern. My y was 2, my new y stayed 2. For j, my y was 0. For the new j, it stayed 0. For L, the y coordinate was -4. It stayed a -4. So it appears that nothing has changed for the y coordinates, only the x coordinates. So now is the time when you guess and check to see what can you do to the original x coordinate to get the new one. Okay. Well, I want to go from a 1 to a -9. So if I take 1 and I multiply it by -1 and subtract 8, that's going to get me to a -9. You kind of have to play around with this. What do you multiply it by? What do you add or subtract it by? Let's test it out with the 5. I'm going to take the -5 times a -1 and subtract 8. That is 5 minus 8, which is -3. So far we've gotten 2 out of 2. We're going to take the 4 times a -1 minus 8, which is -4 minus 8, or -12. So what we're going to do is take the original x value, multiply it by a -1, and subtract 8, which is -x minus 8. The y value is going to stay the same. So now we're ready for our point-to-point rule. Point to point. We're going to reflect the figure, and sometimes in your book they will say italicized T, and then somewhere else below it they'll say where T is the line x equals -4. So you kind of have to look at the key or look at the example to figure out, do they want you to put the line in there or the T in there? It just depends. So we're going to take every point x, y and put an arrow. And for the x, it's going to be a -x minus 8. The y will stay the same. And that is your point-to-point rule. It really is guess and check to figure out something that works with the x coordinate. Many times it's going to be multiply by a -1 or just add a number. So you have to try different combinations until you find one that works for more than one of the corresponding points. All right, that is everything for today. Have a good afternoon.